This conference will now be recorded.
Hey, hello everyone. In today's session, we'll try to understand about what is load balancer or reverse proxy. Why do we need a load balancer or a reverse proxy? And the various types. We have a different types of load balancers also. Based on the implementation, we have different types of load balancers. Based on the OSI layer that they will operate on it, also we have a different types. So we will try to understand about the various types of the load balancers based on the implementation, and based on the OSI layers also we have a load balancers, and how that load balancers will work, and what is software load balancers, and how we can configure a load balancers, software load balancers using such as NGINX. We'll try to understand. And once we are clear about load balancer, reverse proxy, and its functionality, later in further sessions, we'll try to understand about what is DNS, how that DNS works, and what is SSL and TLS certificates, and how we need to secure our application using SSL and TLS with the HTTPS protocol, and how it can be done. We'll try to understand in a detailed way. So first, what is load balancer? Why do we need a load balancer? So load balancer is a system. Load balancer is a system that can be a hardware load balancer or a software load balancer. We have a cloud managed load balancers also. We'll try to understand in some time. Load balancer is a system that will distribute incoming traffic, incoming application traffic across multiple servers called a server pool. So why do we need to use a load balancers? So the load balancer is going to be a system like a hardware load balancer or a software load balancer, or it can be a cloud managed load balancers that will distribute the incoming traffic, incoming network traffic or application traffic across multiple systems called server pool. It is used to ensure, these load balancers are used to ensure no single server is overloaded. So we can maximize the performance and we can achieve availability and reliability. So this load balancers will act as a traffic cop. This load balancers will act as a traffic cop, sit in front of your servers and directing incoming request coming from the clients to the most appropriate systems or servers where our applications are hosted based on the predefined algorithms, load balancing algorithms or health checks, right? So this load balancer is like a device, a system that can be a hardware or a software. Load balancer is a device that is going to sit between the users and a group of servers. Users and a group of servers. It is going to sit in between the users or a clients and a group of systems or a group of servers where our application is hosted, and it acts as an invisible facilitator. It will ensure all the servers are equally shared, or all the servers are all the resources are equally used or equally distributed, like that. Let's say these are like end users, these guys are like end users and clients, and these are like our application servers or web servers, whether you have developed a static website, or maybe you have developed a dynamic website, or it's a API based application. Like here in these servers you have deployed your app. That can be even static website, that can be even static website, static web application, or it can be a dynamic web application developed in Java, Python, Java, or maybe any other programming language, or it can be a API based application In these servers we have hosted our application, let's say. If it is a dynamic web application and a three-tier architecture application, maybe that application may internally talk to the database also. These application systems will internally talk to the database systems also. But here, this load balancer is like one system, and that is going to sit between the clients and the servers. This is the clients users, these are the servers, and this is going to sit in between the clients and servers. It will distribute the incoming application traffic to the servers. It will distribute the incoming application traffic to the server, so that no single server is overloaded or overwhelmed. So we can maximize the performance, availability, reliability. And this load balancer is going to distribute the incoming client request to the most appropriate systems in the back, in this server, in this backend, right? Based on the load balancing algorithms, or there is something called health checks. This load balancer also will perform the health checks. This load balancer also will perform the health checks. If any server is unhealthy, the load balancer will stop sending the request to this server. First of all, why we need to use this? What is the problem? Suppose, what is the problem if we are not going to use this load balancer? Let's take a scenario. Let me explain with a diagram also. Let's imagine you have only one system. Let's imagine you have only one server. This is your system. That can be in on-premise or a cloud, that doesn't matter, guys. So here, let's say this is your one server, one system, one VM, whatever you call it. This is one server. You have some OS. In this server, you have some OS. Obviously, will have some OS. Most of the time, it can be Linux OS. Let's say here you have a OS, operating system. Let's imagine. And in this OS, you are going to install required softwares and configurations. In this system, you are going to install required middleware softwares and configurations. It's a dependencies. Then you are going to deploy your application. Then you are going to deploy your application package. That can be Java. I mean, it's a dynamic web application, static web application, that doesn't matter here. Let's say you are going to deploy your app. This is your app, let's say. Like this is your hardware. This is your hardware, like a CPU, memory, storage. Let's imagine this is the hardware. This is your server. That can be a physical machine or a virtual machine, that doesn't matter. That can be a physical machine or a virtual machine, that comes with some kind of hardware resources, system resources, or a hardware resources. Let's imagine the capacity of the system is 4 core CPU. We have, let's say, 8 GB memory, just to give an example. Some kind of a storage disk. In this, you are going to have a OS, and you are going to install required softwares and configurations. You can deploy your application. Like we already discussed, what is virtualized deployment, physical deployment, right? If required, we can run this application also as a containerized deployment also. So we already discussed in a detailed way what is a traditional deployment or a physical deployment, and what is a the drawbacks of this traditional or a physical deployment were, why we started following a virtualized deployment or a virtual machines, and again, what are the challenges or drawbacks with that virtualized deployment, what is containerized deployment, and what are the advantages of containerized deployments, how this Docker Kubernetes can be used for deploying and managing our applications as a containers. So there is one video, if you guys missed in our YouTube channel, right? There is a detailed video. I hope you guys can go through this if you have not already went through. So here our YouTube channel link is there. This is Rushi underscore technologies, right? So here you can see there is a video on this virtualized deployment versus containerized deployment. Very, very important. So that doesn't matter here. Now load balancing, you can load balance your applications deployed in a physical deployments or virtualized deployment. Even your applications are running as a containers also, you can distribute the traffic to the containers also using load balancers. Now for better understanding or for easy understanding, now let's say this is not a containerized deployment, it's a virtualized deployment where your applications are deployed directly in the servers. This application can be a Java based application or Python based application or .NET or Go language, or even it can be a static website running in Apache HTTPD or maybe NGINX. That NGINX can be used for multiple purposes. We will discuss that. NGINX can be used for hosting a static website. At the same time, NGINX is like a software based load balancer or a reverse proxy. We'll understand that. But for now, let's imagine this is one application deployed in some server with some resources. There is no direct access we are going to give to this server to the end customers. Let's say we have a users, we have a users, we have a users, especially let's say external users. Let's say take external users like the end users who are part of external network or from internet. Let's say you are one user. Let's imagine this is me, Balaji. Okay, and this is where the application is deployed. Now this guy is from internet, and there is no direct access given to that application deployed in the server. Multiple reasons. One is this server, if you are giving a direct access to this server should be having a routes to the internet with public IP, because this customer is in internet. This, if there is no public IP and there is no routes to the internet, this customer will not able to access this application. But that is highly not recommended. Direct basically our applications are hosted in private servers. We should not host in a public server because of security, network security. Anyone can breach into this server, anyone can get into this server, and they can mock, I mean, so they can hack your data, they can manipulate your systems, and they can manipulate the data directly, direct access to the server. So we should not give. One reason. Second reason is one more important. Okay, one customer, fine, but let's say you have a thousands of customers accessing the application. Let's say thousands of people accessing this application. Let's say this is one more person. This is like this, you have so many people, like lakhs of people or thousands of people accessing this application directly, right? Whenever any request comes to this application or a process, whenever any request comes to this application or a process running in this system, whenever any request comes to this application or a process running in the system, in order to serve that request, in order to serve the request, that process will try to consume some system resources or hardware resources like CPU memory. If so many requests, so much load, we call it as a so much a traffic or a load. If so much a traffic or a so much load comes to that application, right? Then the application or a process running in the system will try to consume hardware resources or a system resources in order to serve that request. So if that application or a processor doesn't have enough CPU, enough memory, more requests are coming simultaneously. If that application or a process doesn't have enough CPU, what will happen to that process? That process becomes slow or a hung. That process becomes slow or hung, very slow response, or it will hung and it will not give any response or timeouts. These type of errors will happen. Suppose if any application running out of memory means RAM, let's say this is the available memory, but so many requests came, so many requests, or so much traffic, we can say, so much traffic. In that case, what will happen to that process? OVM killed, out of memory killed, out of memory killed. If that process itself is killed, then again that application is not accessible to the customers, your application is down, there is an outage. More than this, again, you are giving a you are giving a internet access to this server directly, and anyone, even the hackers also can get into the servers via public networks. They can connect directly, and they can hack or manipulate the systems or manipulate the applications and its data. That is one problem. Another problem is a single server, single point of failure. Single server, single point of failure again. So here you may need to scale this application again. If you are using only one server, again you may need to scale this application. So here there are two types of scaling, as you guys already know. One is vertical scaling, another one is horizontal scaling. Vertical scaling means increasing the hardware capacity of the system itself. Let's say instead of 8 core CPU, instead of 4 core CPU, if you are making it 16 core CPU, 32 GB RAM, upgrading the hardware of the system, same system, this is called as a vertical scaling. Even though you vertically scale, even though you vertically scale this application, is this system, still we can consider this as a single point of failure. Let's imagine, even though you have a more resources, hardware resources, but imagine there is a hardware failure, network failure, or OS failures, then again that application is down. It is like a single point of failure. So we are going to bring multiple, instead of vertical scaling, most of the time we can go with horizontal scaling. So horizontal scaling means we are going to replicate the same application into a multiple instances or a multiple servers. We are going to replicate that application into a multiple instances or a multiple servers. Same application we are going to replicate into a multiple system. But how customers can access them? Not like you can't ask one customer to access this, another customer to access this server, like that. So this is where you are going to bring a load balancer. This is where you can bring a load balancer. You can bring a load balancer that can be a device or a system. It will sit in front of the clients, in front of the clients, and in front of the servers. Between the clients and servers, you will bring a load balancer. You will bring a load balancer. There is something called reverse proxy. There is a slight differences between the reverse proxy and load balancer, but some will act as a both reverse proxy as well as load balancer also. You are going to bring a load balancer. You are going to bring a load balancer that will sit in front of our, I mean to say, between the clients and between the users, between the clients and between the servers. Let's say you may have so many clients, that is fine. So we are going to use this load balancer to distribute the incoming traffic, traffic application traffic or a network traffic. So we are going to use this load balancer. All the requests will go to the load balancer. This load balancer can distribute the incoming traffic across these servers. And this is going to distribute the incoming traffic across all these applications. Now, what is the advantages of this load balancer, right? So we can, as I already said, we can maximize our performance because there is no single server where all the load will be handled. So no single server is overloaded or overwhelmed here. The load is distributed. The load is distributed across all these servers. We call it as a server pool. We call it as a server pool. Server pool. So here the load balancer is a system that can be a hardware or a software. It will distribute incoming traffic, incoming network traffic or application traffic across multiple servers. It is used to ensure no single server is overwhelmed or overloaded, so that we can maximize the performance also and availability and reliability. So let's say, let's imagine there is a 1 lakh people are accessing 1 lakh requests coming. Now all the requests will go to this load balancer. This load balancer may distribute based on load balancing algorithms. We will discuss about the load balancing algorithms also. Predefined load balancing algorithms, we have round robin, sticky session, least connection, weighted, like that. So maybe 35,000 request is going to this system, and the remaining 35, I would say, maybe some request 30,000 clients request is going to this system, remaining maybe going to this system, like that. So no single server is overloaded, no single server is overloaded or overwhelmed. So load is being distributed, load is being distributed, so that there is no overutilization of the resources, right? Only this server is receiving these many requests and it is capable of supporting this much load. Like this load is distributed, so you can achieve better performance in the application also. Next, one more thing is, can we avoid single point of failures? High availability can we achieve? What does it mean, single point of failure? Even though one of the instance is unhealthy, that application is down, maybe server went, something went wrong. So even though one of the instance in this server pool is down, so still we have some instances, still we have some instances to serve the traffic, and this load balancer can perform health checks also. It can perform the health checks also, so that it will shift the traffic away from that unhealthy instances. So if something goes wrong with this, load balancer will shift the traffic away from this instance. It will not send the traffic to this server. So we can achieve better performance because it is distributing the load, and we can achieve availability, availability and reliability, because even though one of the instance is down, we can avoid the single point of failure, and still the servers are available to serve the traffic. This is what actually load balancer does. This is what actually a load balancer does, right? And again, in the background, this application deployed in these servers can talk to any other applications, or again, databases. If it is a 3-tier application, right, it can talk to database also, maybe running somewhere, that other concepts. But this is how the load balancer will work, you can see. So what is the purpose of this load balancer? Traffic distribution. So load balancer, how it works: traffic distribution, incoming traffic, that request coming from these clients received by the load balancer, then it uses some algorithms. We have some algorithms we will discuss, like round robin, least connection, sticky session, and it is going to use those algorithms to determine the best server among this pool of servers or a group of servers to handle each request. And again, health checks. Load balancers constantly monitor the health of the servers. If a server becomes unresponsive, it is not responding, the health check is failed, then the load balancer will automatically redirect the traffic to other servers, healthy servers. It is going to redirect the traffic to healthy servers, ensuring continuous service. So this load balancer will ensure continuous service is giving to the clients. And again, session management, like there is something called a sticky session, right? If load balancers can use to manage the user session, ensuring that user subsequent requests are routed to the same server for consistent experience. Session based application, sticky session. And load balancer can easily handle increased traffic. Load balancer can easily handle increased traffic by adding more servers to the pool and distributing the load across them. Again, maybe you have a three servers initially, but still so many requests are coming, so much load is coming, demand is there. It will make it easy to scale. What you can do, you can again add one more server. You can add one more server to this load balancer. You take one more system, deploy the application or replicate the application. This you can add to the load balancer again, so that it is easy to scale in, scale out. Suppose still so much traffic is there, you can increase more servers and add those servers to the increase more servers and deploy that application to these servers. I mean, say deploy that application in these servers, then deploy that application in these servers, then add the server to the load balancer, so that it will distribute the request to this server also. Like this, you can scale in, scale out. When there is a demand, you scale out, increase the servers. When there is no demand, you can scale down, scale in, scale out. Scale out means increase when there is a load. Scale in means decrease. There is a If there is no load, you can reduce the number of servers and you can only have a few servers, minimum servers, like that. So this load balancers will can easily handle increased traffic by adding more servers to the pool and distributing them across this. So why do we need to use load balancer? As I already said, if one server fails, the load balancer will route the traffic to the other healthy servers. So a load balancer will ensure high availability by continuous monitoring the health of the servers, that actual servers to which load is distributed. If a server becomes unresponsive or a fails, the load balancer will automatically reroutes incoming traffic to other healthy servers in that pool. It will minimize the downtime and maintain the seamless access for users. And scalability, as I already said, you can easily scale the system horizontally. If I am using this load balancer, we can easily scale the systems or applications horizontally by adding and removing servers without affecting users. A load balancer will help you. A load balancer will help your system, your application. Basically, this load balancer will helps your application to grow or shrink easily. When more people, more load on your application, use your when more people when more people are using your website or application, when more people are using your website or application, you can add more server to handle the extra traffic. When the fewer people are using it, you can remove some servers to save the money also. The load balancer makes sure users don't notice any change. It will quietly send the traffic to the available servers. And we can achieve performance optimization. The load balancer will send the user's traffic or user's request to the servers based on algorithms that has the lowest load or closest to the customers or lowest load. This help your website or application to load faster and work better for everyone. And the fault tolerance, failover failover and health checks failover and health checks ensure no traffic is sent to unhealthy servers. The load balancer checks if every servers are working properly. If a server has a problem, it will stop sending the traffic to that server, uses healthy servers instead. This keeps your application running smoothly even if something goes wrong. And security abstraction, most importantly, this reverse proxy, you can use this load balancer to secure the your systems also. The load balancer will hide the real IP addresses of your backend servers. So you are not directly exposing your backend servers or your systems where your application hosted to the clients. You are hiding it is there is a load balancer sitting in front of that servers, right? So this load balancer will hide the real IP addresses of your backend servers. This makes it harder for attackers. It is going to make it harder for attackers to reach them directly. And you can help your internal systems more secure. So what does it mean now? So here, this can be a private servers now. This can be a private servers, and you no need to expose these servers to the internet. This can be a private server without internet access, without routes to the internet, whether they are running in on-prem, whether they are running in cloud, that doesn't matter. You can hide these servers directly. You are not exposing these servers directly, so you are hiding these servers by using a load balancer. So you no need to expose the servers, these servers to the internet. You know, you can hide the IP addresses of these actual servers, because end users will only reach this is going to internally forward the request. So there is no direct access to these servers, you are not allowing, which means they can't bypass this. They can't bypass this. They can't directly reach these systems. This is not possible. You are bypassing. You are not allowing this, right? Everyone has to come via this in order to access that application. We are only just exposing that application. So, and also here there is a concept of security also. You can secure this in the network by creating them in a private subnets. But this can be in a public subnet, same network. Maybe this is how it can be. Same network, this is a separate subnetwork, these are in a separate subnetworks, right? This can be a public subnet, this can be a private subnet. So since this load balancer you have placed in the public subnet, external traffic can flow to this load balancer. This load balancer is also one type of process, one type of program. It will accept the request on some port, and request comes to this load balancer on that port. That load balancer will internally forward the request to these servers, but we need to define the settings. Load balancer doesn't know which servers it has to forward the request and on which port. In this load balancer you are going to define that proxy rules. Reverse proxy rules are settings. Reverse proxy rules are settings, like that. That is what it is going to do. And again, we have something called http and https concept. Even though you are making these applications available via this load balancer, but if anyone is accessing on http protocol, then again, whatever data that is being sent from end user, let's say this end user is communicating with these servers using load balancer, fine. But let's say this is running on http, hypertext transfer protocol. If this customer is giving some kind of a data, that can be his username, passwords, or maybe credit cards, debit cards, some kind of a data. The data is communicated, the data is exchanged to these applications deployed in these servers via load balancer. But if it is using http protocols, then the data will be sent in the network. The data will be sent in the network in a plain text format as is. Again, if the data is sent in a plain text format, again, to these load balancers, again, in the especially in the public network, especially in the public network, if the data is being sent in a plain text format, again, is it possible for the attackers or middlemen to see what type of data, I know what exactly what communication is happening between this client with this load balancers or servers, they can easily understand if the data is being sent in a plain text format, HTTP. So here in this load balancer, you can configure something called SSL and TLS certificates, encryption in transit using SSL and TLS certificates. Using SSL and TLS certificates, you can enable encryption in transit when the data is being exchanged from this clients to this load balancer, especially your in the public network. It can use certificates to secure the data. From here to here, you can make it HTTPS. But if required, this internal from this load balancer to this, even though if it is HTTP also fine, HTTP also fine, because this is private. From here to here, it is private. From here to here, it is private. From here, it is like a private network, internal network. Even though if it is HTTP also here, fine. But in the public network, till it reaches this load balancer, you can make it HTTPS. What is this HTTPS, HTTP? What is that certificates? Why do we need? In a detailed way, I will explain again. But for now, understand, you can configure in this load balancers, you can configure some kind of a security also, right? Can be configured with security features like SSL or a TLS termination, acting as a security layer. Reverse proxy, it is proxying your real servers in the background. Reverse proxy security, it is going to secure the data that is being exchanged between the clients to the servers by configuring SSL and TLS certificates there. The data which is going to be exchanged between the load balancers to that clients will be encrypted using that certificates. Even though the middleman can see some data is flowing, but they cannot understand because that is encrypted using some kind of a hashing security certificates. So unless until they have the keys to decrypt, they cannot understand. So you can configure SSL and TLS certificates, and you can offload that SSL and TLS certificates also at the load balancer. Offloading SSL and TLS termination also you can do. SSL TLS setup and termination. Termination means from here to here it will be HTTPS traffic. The data will be encrypted and sent to this, and here it you have configured the keys here. This can offload this HTTPS request to HTTP again. It can, using its keys, it will offload or terminate that HTTPS. From here to here, it can send HTTP again, plain text also to these servers. Like that you can do offloading. SSL TLS setup and offloading also you can do. So here SSL TLS is a encryption protocols. This SSL stands for secure socket layer. This TLS stands for transport layer security, right? This SSL and TLS are like encryption protocols that is going to secure the data transferred between the client and server. There is something called encryption in transit. Transit means when the data is being sent transit over network, there will be encryption. It is going to encrypt the data and send over network. So this is setting up SSL and TLS means you are enabling HTTPS for your website so that your users data is encrypted and sent over network. This you can do. So people call it sometimes reverse proxy, load balancer. So what is load balancer? What is reverse proxy? What is difference between these two? What is load balancer? What is reverse proxy? And what is difference between these two? So a load balancer is distributing the traffic across multiple servers. The load balancer is going to distribute the traffic across multiple servers so that no single server is loaded, improving application performance and reliability. Reverse proxy is also one type of system only, that is again going to sit between the external kinds and internal application. The reverse proxy also can act as a load balancer, but more than load balancing, it will have advanced features also. So reverse proxy is also a server that is going to sit between external clients and internal application. Reverse proxy also can do the load balancing, but they will provide advanced features like SSL termination, caching, security. Reverse proxy is more concerned with the limiting and safeguarding the servers. So you are going to use these reverse proxies for securing the internal servers and safeguarding the servers. You are safeguarding the servers using reverse proxy. Reverse proxy also can does the load balancing. While both load balancer or reverse proxy, both can handle the traffic, both load balancer or maybe a reverse proxy, both can handle the traffic. It can distribute the traffic and it will improve the performance. But each have their distinct primary functions. Load balancer and reverse proxy have its own primary function, but both can distribute the traffic. But some softwares will act as only load balancer. Some softwares will act as only load balancer. Secure. We can't secure the internal servers. You can't set up SSL or TLS termination like that. But some tools, many tools acts as a both load balancer as well as a reverse proxy. For example, you take NGINX. NGINX can be used as a load balancer or a reverse proxy, or NGINX can be used for deploying a static website. You can use NGINX for deploying some applications also. If required, same NGINX can be used for a load balancer or a reverse proxy. Many tools acts both a load balancer as well as reverse proxy. For example, tools like NGINX, HTTPD, HA proxy can perform both. It can perform both roles depending on their configuration, right? A load balancer is going to spread the traffic across multiple servers, so no single server gets overloaded. It will improve the performance and uptime. A reverse proxy is going to secure. A reverse proxy is going to secure. It will protect your internal servers. You are hiding them, and also you can it will help with security, caching, SSL, TLS setups, URL routings like that. So the load balancer primary functionalities is distributing incoming traffic across multiple servers to prevent overloaded or improved application responsiveness. So it will handle multiple servers. The load balancer focuses on distributing traffic to maintain. It is going to distribute the traffic. It is going to focus on distributing the traffic to maintain performance and uptime. This again, this load balancers are different types again based on the implementation. We have a hardware load balancers, we have a software load balancers, we have a cloud managed load balancers. We'll discuss in some time. And this load balancers uses something algorithms to decide where it has to send the traffic. This load balancers uses some algorithms like round robin, sticky session, least connection, weighted, like this to decide to which server that incoming traffic has to be sent, which client traffic has to be sent to which server. It can decide using this algorithms. So we can use this load balancer to distribute the traffic to the web servers, not only web servers. Suppose in real time you have a database servers. In real time you are not going to have a single database also. You may have a multiple database instances again for high availability in the database also. If required, you can have a internal load balancer for database, external load balancer for your applications, like that also. You can have a load balancers not only for applications. If required, you can use load balancers for a database also, or other backend resources. That is the load balancer functionality. The reverse proxy functionality, again, it is also going to forward the request to the appropriate servers. The reverse proxy also does the load balancing, but more than load balancing, again it will hide the original server, the origin server or a original server. It will protect the original server. So this load balancers and reverse proxy is going to do load balancing as well as some additional functionalities. So this reverse proxy also sit in front of one or more backend systems. This reverse proxy also will receive the client request. and it will forward them to appropriate server. Then it is used with single server or a group of server. You can use this reverse proxy for single server also. Let's imagine, forget about load balancing. Sometimes let's say you are using Jenkins, you are using Nexus or a Sonar Cube, but that is a single instance. But Jenkins master slave architecture is different. Let's say you are using Jenkins also has to be protected from internet. So let's say you have a Jenkins instance that can be a single server. Let's say this is your Jenkins server, this is your Jenkins server, right? So you need to hide this Jenkins. Here you can bring a reverse proxy. This can route the traffic to the single instance also, but we can protect this here. This reverse proxy or a load balancer, this reverse proxy does the load balancing functionality also, but here you can configure SSL and TLS securing. You can hide this, you can protect this system just by exposing this Jenkins only. But Jenkins can internally talk to the agents that you are, that is not a that is different, that is not a load balancing concept, that is a master slave architecture, different concept, right? But this Jenkins controller can be protected or hide this via reverse proxy. So this reverse proxy can be used with single server or a group of servers also to distribute the load, and it will enhance the security. It will enhance us the security by hiding the origin server, and it is going to handle SSL and TLS termination, and it can improve the performance through caching if required. If it is a, you can serve the static content of your application directly from this reverse proxy instance also. Instead of serving the static content from application instances, you can serve the static content from this reverse proxy instance also if required. And here security, we can, it is going to provide a features like filtering, content based filtering, request modification, access control. You can control the access here itself. Instead of handling the controlling the access at actual servers, you can use content filtering, request modification, access control, these type of features. So we can use this for protecting web servers. This reverse proxy can be used for protecting the web servers and caching the content, handling SSL and TLS, and load balancing also. So reverse proxy is like a going to do load balancing as well as some kind of a security also like this. So I hope now everyone clear what is load balancer and reverse proxy. But some tools is going to act as both, like NGINX, HTTPD, HA proxy, these type of things. Now we have a different types of load balancers again based on the implementation. So we have a different types of load balancers. Load balancers are categorized by their implementation, like hardware load balancer, software load balancer, or virtual or a cloud managed load balancers. Again, we have a different types. Load balancers. Load balancers are categorized. Load balancers are categorized based on the implementation, by their implementation, by how we are implementing that load balancers. By their implementation, they have categorized. Like we have hardware load balancers. We have hardware load balancers. We have something called software load balancers. Software load balancers. And we have something called virtual virtual or cloud managed load balancers, like this. So again, this is based on their implementation type. But again, whether you are using a hardware load balancer, whether you are using a software load balancer, whether you are using a cloud managed load balancer, again they, based on the OSI layer that they are operating also, we have some types. at what OSI layer you are operating that load balancer. Based on the implementation, we have these three. But whether you are using a hardware load balancer, whether you are using a software load balancer, whether you are using a cloud managed load balancer or a virtual load balancer, so by the OSI layer they are operating. based on the Based on the OSI layer, based on the OSI layer, at what layer in the OSI you are operating that load balancer. Based on that, there are two types. Again, that can be hardware or a software or a network. Basically, that can be a hardware load balancer, that can be a software load balancer, or that can be a virtual or a cloud managed load balancer. You can configure that load balancers at some OSI layer, right? So based on the OSI layer, they operate means we are configuring. Based on the OSI layer, they operate, right? We have some types again, like a network load balancer, application load balancer. Based on the OSI layer that they operate, right? We have some types again. One is a network load balancer, or we call it as a layer 4 load balancer. Very very important in the interview standpoint also. What is layer 4 load balancer or a network load balancer? This is called as a layer 4 load balancer. There is something called layer 7 load balancer. We call it as an application load balancer, a layer 7 load balancer. So we'll try to understand what is this layer 4. This layer 4 works at the connection level. It is going to distribute TCP and UDP traffic based on the network level implementation. They are ideal for high performance and low latency applications, right? This is going to distribute. This network load balancer is going to work at layer 4. There is OSI model. We will discuss about that. What is OSI? Open systems interconnection. That is one model defined by ISO, international standardization, right? For any networking, any two systems has to exchange some data or communicate in the network. It has to go through some kind of a layers and protocols. So there are seven layers in that OSI model. So this layer 4 or network load balancer works at the basically layer 4 using TCP and UDP protocols, right? And we will discuss in a detailed way what is this network load balancer, application load balancer. So further we will discuss. But for now, they have categorized based on the OSI layer that they are operating. Basically, this layer 4 load balancers distribute the TCP and UDP traffic based on the network level implementation. They are ideal for high performance low latency applications. And this layer 7 load balancer works at application layer. It is going to route the traffic based on content also. Host based routing, path based routing, header based routing, these type of routings also you can do. So based on your requirement, you can configure a load balancer at layer 4 or layer 7, like that we will see. First, what is hardware load balancer? What is software load balancer? What is this virtual or a cloud managed load balancer? Hardware load balancer means the physical hardware, the physical appliance, the hardware appliance that is going to distribute the traffic. There is something called hardware load balancer. So a specialized hardware. So there is something called hardware load balancer. Basically, a specialized hardware. Basically, this hardware load balancer, it's a special hardware appliance. It's a special system that comes with hardware capabilities. So hardware load balancer is a dedicated physical device. A hardware load balancer is a dedicated physical device used in the networking environments to distribute incoming traffic across multiple servers. Hardware load balancer is a dedicated physical device, physical hardware appliance. The way we have a routers in our home, the way we have a network switches, that hardware, right? Similarly, there is a load balancers of type hardware. That hardware load balancers are a dedicated physical devices used in the network environments to distribute the incoming traffic across multiple servers. Basically, it is like a built-in device, dedicated hardware, basically dedicated appliance. The purpose itself, the purpose is a built-in device designed only for load balancing. That hardware is developed or designed only for load balancing purpose, a dedicated hardware appliance, and it comes with optimized hardware for faster packet processing or a network packet processing. And this hardware load balancers will give very high performance. It can handle millions of concurrent connections at very high data throughput also. This hardware load balancers also can be configured at layer 4, layer 7. Most of the time, it is the hardware load balancers are typically deployed in large enterprise data centers, our on-premise data centers or the physical data centers, where high throughput and reliability and specialized features is required. So here, this hardware load balancers comes with reliability also. It will provide a redundancy. We can set up like active active or active passive kind of a things, and built-in health check for monitoring backend servers also will be there. And we can use this hardware load balancers. Also, we can use to do SSL and TLS offloading, DDoS protection, DDoS protection, web application firewalls, content caching like that. So examples for this hardware load balancer, maybe you might heard something called F5 network. F5 network. There is one company called F5. So there is one that F5 network company is giving one hardware load balancer called F5 Big IP. This is industry leading hardware load balancer with advanced features. And similarly, there is something called a NetScaler, Citrix NetScaler. Citrix NetScaler, or now we call it as a Citrix ADC. That Citrix as a company, they are also giving hardware load balancer. And similarly, we have something called Radware like this, but more widely, mostly used hardware load balancer is that F5 Big IP or Citrix NetScaler or Citrix ADC. These are like a hardware, a specialized hardware. This load balancer, this load balancer, can be a hardware, can be a hardware load balancer that comes that is developed or designed only for load balancing purpose. That is developed or designed only for load balancing. This is also one type of a server, but not for deploying applications. This is also one type of a system, but not for deploying applications, only designed for distributing the traffic, load balancing purpose, hardware load balancer. And this hardware load balancers are extremely fast and reliable, and we can have a advanced enterprise features, SSL offloading, caching, and it is suitable for large scale mission critical applications, that is like a banking application, telecom application, healthcare application, especially the people who are still using on premise data centers, right? They can have the hardware load balancers used to distribute the incoming traffic to them, and it is going to give a better performance. But the disadvantages is very expensive, guys. That hardware is very expensive, very costly, and you need to take the support from that vendor, ongoing support from that vendor, the vendor who provided that hardware load balancer, ongoing support, and initial cost also very expensive. And again, we need a specialized skills to configure and manage that hardware load balancers, and it is very less flexible. It is very less flexible compared to the software load balancers or a cloud managed load balancers. It is little flexible, but these hardware load balancers are best suited for a large enterprise with massive traffic, and again, like our own our own data centers we are using. So you can have this type of hardware load balancer. But for small organizations or for small applications or a cloud native applications, we are using cloud computing, cloud services, or maybe even though you are using on premise data center for small scale applications or cloud native applications, you can go and use a software load balancers or a cloud managed load balancer. But first category is hardware load balancer. I hope everyone clear what is hardware load balancer. Example, F5 Big IP, Citrix, Netscaler, these type of hardware. Now there is something called software load balancers. There is something called software load balancers. So you can use some software also uh, to perform this load balancing, load balancing, SSL, TLS, that software load balancer or a reverse proxy. You can use some kind of a software also that can perform the load balancing and reverse proxy features. A software load balancer is one application again. A software load balancer is one application or a service running on some system. Let's say this software load balancers also one type of a soft application or a service. That software load balancer is a one type of a application or a service or a software basically. So you can use that software load balancer with some system. You can take any system. In that system you are going to have a OS. You are going to have a OS. You are going to have a OS, right? In that system, in that OS, you can install a software. It will perform the load balancing functionalities, reverse proxy. So this software load balancer is one application or a service that will distribute incoming traffic across multiple servers. And software load balancers are flexible, cost effective, easy to deploy both in on-premise as well as cloud environments also. So you can run on the your VMs, your systems. So software load balancers, you can run that software load balancer, basically that application or a service. It will does the load balancing and reverse proxy. So you can run, or you can install that software load balancers on Linux or Windows servers also, or if required as a containers also. Suppose you are using a containerized deployment, you can run that load balancer also as a container. You can directly run in a virtualized deployment or a physical deployment, or if required you can run that load balancing also, that software load balancer also as a container. If you are using tools like Docker, Kubernetes, you can run that software load balancer also as a container in that systems. But if you are not sure about what is physical deployment, what is containerized deployment, what is virtual deployment, so I already explained, but if you missed, you can refer this video, as I already said in our Rushi Technologies. This, but anyhow, in further sessions, as part of our DevOps with AWS training, we are going to detailedly discuss about what is containers, why do we need containers, what are the advantages of containers, what is container orchestration. In a detailed way, we'll discuss. But for now, let's understand this can be a software load balancer directly installed on that server, not as a container. Okay, so you can install directly in a Linux or Windows operating systems. Maybe you can run it as a container also, maybe directly a virtualized deployment. And again, this software load balancer works at the layer 4 or layer 7 also. And the software load balancers are more flexible. You can run on bare metal systems, that is physical machines, or you can run on virtual machines, virtualized deployment. Even you can run these load balancers as a containers also. It can be easily integrated with the Docker, Kubernetes also if required. And the software load balancers also supports reverse proxying, load distribution, health checks for backend servers, SSL and TLS termination, caching, all these things like this. So there are so many softwares that we can be used for this load balancing and reverse proxy. Software load balancers you can run on VM or containers also if required. So example for software load balancers, we have so many ways. Example for software load balancers, we have something called NGINX, something called HA proxy, we have something called Apache HTTPD, Apache HTTPD, HA proxy, NGINX, Terrafic, NY proxy. Like that there are so many. And the advantages with low cost and open source, many softwares that we can use as a load balancers for reverse proxy purpose, that is open source, much cheaper than the hardware, and highly flexible. You can run anywhere. You can run anywhere, maybe in VM container or bare metal. You can use with the cloud also if required, or on premise also you can require, like that. But the disadvantages is performance is depends on the hardware of your server. Performance is depends on the hardware of your server, because this is where you are running that load balancer, software load balancer, right? Suppose that can be NGINX or HA proxy. The performance of this load balancer or a reverse proxy is depends on the hardware of the system on which you have configured. The performance is depends on the server hardware, based on the CPU memories available on this hardware. The performance is going to vary for this load balancer, and it is going to have a limited throughput compared to the specialized hardware, like that. And basically you can use for small scale applications or a medium scale applications also. You can use for cloud native applications, microservices, like this. Web application with medium to high traffic, we can use this software load balancer also. So software load balancer is best for flexibility, cost effectiveness, but it is ideal for modern DevOps microservices and scalable web applications from small scale to large scale also. But the performance is going to depends on the hardware of the system where your load balancer is configured. This is software load balancer that you can use like Nginx, HA proxy. Again, that can be directly deployed in the system as a virtualized deployment, or you can run it as a container also, Docker containers. Now, in this load balancers, you are going to define the rules. Rules. If any request comes to this, we can say forward the request to this server IP. You can give some IP. This server IP and port which application is running. This server IP and port that application is running. So in this load balancer, you can configure the rules. Like if request comes to this, distribute the traffic to this group of servers, like that you can mention. That is called as a configurations, Nginx configurations, HA proxy configurations, like that. Now we have a one more type. We have a one more type, that is cloud managed load balancer, or a virtual or a managed cloud managed load balancers. Virtual or a cloud managed load balancer. So here, if we are using a software load balancers, that you can configure in cloud also. But if I am using a software load balancer, that you can configure in cloud like AWS, Azure, GCP also, or maybe in on-prem also. But if we are using this software load balancers, even in cloud also you can use it. But we need to provision this server, this hardware, to set up this load balancer. You need to create a systems, and you need to make sure your systems are available, scalable. You need to take care about our server availability, scalability, and installations of the software load balancers, configuration of the software load balancers. If we are using this software load balancer, that you can even use in cloud like AWS, Azure, GCP also. You can simply create one EC2 instance. In that EC2 instance, you can set up this Nginx or HTTPD. Otherwise, you can create a EC2 instance, and you can install Docker. You can create this Nginx also as a container. But here, if I am using the software load balancers, you are responsible for creating the required infra to set up the load balancer. You are responsible for configuring and managing the load balancer. But if something goes wrong with this hardware itself, this is hardware, the load balancer running in this hardware, I mean to say that Nginx or HTTPD again not available. So you need to take care of this infrastructure provisioning, infrastructure management for this load balancers to work properly in case of software. But there is something called virtual load balancers or a cloud managed load balancer. Suppose you are using a cloud computing, cloud services like AWS cloud, Azure cloud, GCP cloud for running your applications or your workloads. There A virtual load balancer is a software load balancer again. That virtual load balancer, a cloud managed load balancer, is also a software load balancer. But we no need to create that. We no need to manage that. So a cloud managed load balancer is again, it is in the background, it is like a software load balancer only, software load balancer only. But this cloud managed load balancer is a fully managed service offered by cloud providers like AWS, Azure, GCP, where the vendor only will handle the provisioning of the servers, scaling, high availability of that load balances. Again, they will only configure, maintain, manage the load balancer for us. This cloud managed load balancer is like a fully managed service offered by cloud providers like AWS, Azure, GCP, where that providers, that vendors only will handle the provisioning. Provisioning means creating the required compute to set up this load balancer. They will only take care of provisioning, and they will only take care of scaling. Suppose so many traffic comes, this load balancer also has to be scaled, right? In order to handle so much traffic coming to this load balancer is like a front end. I would say front front facing system. If so many requests come, this load balancer also should have more resources, so that it can receive and forward. This is just receiving and forwarding, but it should have some resources to handle that receiving and forwarding also, right? So if I am using cloud managed load balancer, they will only take care of provisioning this infrastructure. They will only take care of scaling, that can be virtual, vertical or horizontal scaling of the load balancers again, and they will take care of high availability of the load balancing for us. But this cloud managed load balancers is like a platform as a service. That load balancing platform as a service offered as a pass platform, load balancing platform, right? So completely managed and scalable by cloud, and a pay as you go model. And this cloud managed load balancers can integrate with other cloud services. This cloud managed load balancers can integrate with other cloud services like DNS, security groups, auto scaling groups, like that. So example for this cloud managed load balancers, in AWS we have something called ELB, elastic load balancer, and in Azure cloud there is something called Azure load balancer. In GCP cloud also we have a different service names. This is cloud managed load balancers or a fully managed load balancer. So we no need to worry about provisioning the required infra to set up that load balancer. We no need to worry about configuring and managing the availability and scalability of the load balancer. They will take care. So you just create a load balancer like ELB. You just define the rules in that load balancer. If any request comes to that load balancer, to which server it has to forward the request, you are only we are concentrating on application traffic management. If the load internally, they will take care of creating, managing, maintaining the load balancer for us. I hope everyone is clear about this, what is load balancer and what is reverse proxy. What do you mean by this hardware load balancer, software load balancer, cloud managed load balancers, and why do we need these load balancers? And some will act as a load balancers as well as reverse proxy. Now we are going to take this into the next level. I am going to simulate with real environment, right? So in the previous sessions, in the networking sessions, we already discussed about what is network, what is public network, what is private network. Now I will take this to the next level. Now first, I will explain, even though maybe I can directly go and explain cloud managed load balancers like ELB, but maybe let me explain this NGINX, that software, basically software load balancer that we can use in on-prem and cloud also. That also I will show. For now, what we already have a VPC in AWS. We guys already discussed and created a VPC. Now let's say I have a VPC with public subnets, private subnets. Now I can create some servers. This load balancing concepts remains same whether you are using AWS or Azure or GCP or on-prem also, guys. That doesn't matter. So here I have some servers where I will deploy application into multiple instances. Again, if you are using cloud like AWS or Azure or GCP, you already have a concept of regions, availability zones like that. So again, it is not recommended to have all of your application instances in a same availability zone. Even though you have a multiple instances to achieve load balancing, high availability. But let's imagine if you are using cloud like AWS or Azure or GCP, it is not recommended to create all of your application instances in a single availability zone, because okay, even though one of the server is having a problem, but still you have some other servers to serve the traffic. But let's imagine if there is a problem with this availability zone, AWS availability zone or GCP availability zone or Azure availability zone, that data centers managed by that providers, again all the instances in this also will not be available. Maybe some natural disaster happened or some kind of a data center maintenance AWS is performing that time. So it is recommended to distribute these instances also into multiple availability zones. That's why you can create a multiple in each availability zone. You can create a multiple subnets also like this. If required, you can deploy multiple some instances in this availability zone, some instances in this availability zone. These are like your application instances, right? Based on your requirement. Again, you may have a doubt, sir, in how many systems we may need to deploy the application and what type of systems I should use. So people get confused with the real times are in real time, how many servers we are going to have for our application and what type of servers, what should be the capacity of the servers. So there is nothing called real time, guys. Everything is based on requirement. So in how many instances you have to deploy your application and what type of servers or what should be the capacity of the servers, everything is depends on your application traffic, application load. So based on some kind of a numbers, we will go with this. Based on some numbers, we will go with this. Basically, like let's say your application is accessed 1 lakh request, maybe per minute or per hour 1 lakh requests are coming to your application. So maybe 50k requests are coming. Based on your numbers, business numbers only will decide the capacity, number of instances like that. But for now, let's understand. We can take, maybe since it's a learning or it's a understanding, the concepts are same. The concepts are same. This is also a real time only. I am just taking one sample application, but I am not creating very high configuration servers. I am just creating very small T3 dot micro, T3 dot medium like that. But when we are working or when we are using for actual systems, actual application, enterprise applications, so many customers will be there. You are not going to take very less configuration servers. You are going to take, so based on the software or application running in the system, you will take the instance type, and again based on the load expected, you are going to take the instance type, and again multiple instances you will take again based on the load or a demand like that. So this is how you can create that servers. These servers can be in on-prem. These servers can be in cloud like AWS or Azure or GCP. That doesn't matter. We are going to create a servers in which you will deploy your application. Now I can go with the software load balancer also, or maybe cloud managed load balancer. If I am using a cloud like AWS, I can use software load balancer also. Software load balancers means I can create one server, I can create one system again. In this system, I can install that software like NGINX, that NGINX, and this can be running as a container or maybe virtualized deployment. So this nginx I can use to distribute the traffic also if required to these servers. This server is where my applications are hosted. But this nginx I can create in a internet facing subnets, public subnets, so that end users can reach this load balancer. The load balancer and these application instances are in a same network. This can talk to this one privately, but the end customers can access this applications via this load balancer, but there is no direct access to these systems or processors or storages like that. Only they can access this. Now, if required, if it is a three-tier application or databases also, that this application instances can talk to the database instances also, or any other third-party application that is internal. Let's say we have database. Maybe this application instances, all these application instances can talk to the databases also. Again, this database can be self-managed database, or it is like a cloud managed database. Cloud managed database like RDS, or it can be a self-managed. Self-managed means again, as a database admin, you can create a server and you can install the database, and you are taking care of database availability, scalability again, required storage, backups. You are taking care. But fully managed databases also there, that like RDS. So that cloud managed database, so you can use RDS in the background. That vendors, that AWS itself will take care of provisioning the required infra to set up the database instances, and they will take care of configuration in database, availability, scalability of the database, periodic backups also they will take care. That is up to you, right? But this application instances can talk to the database instances. This load balancer can distribute the traffic to the application instances. Like this, you are protecting. And again, here you can configure ssl and tls also. Here ssl and tls certificates you can deploy, so that from here to here it will be https traffic. So in the internet in the public network, from the client to this load balancer, the data will be encrypted and sent. The middlemans cannot understand, because they don't have the certificates to decrypt. The certificates are deployed here, so that this here to here https. And this can be configured with offloading, ssl termination or offloading. So this load balancer itself will offload that ssl and tls request, and from here to here internally it can send http traffic again, like that. So you can use this way. This is how you can use software load balancers also. But nginx can be used for multiple purpose. This you can use for load balancing and reverse proxy. Suppose it is not a static you are deploying a static web application, not dynamic. In these servers also you can use nginx, and you can deploy your static website. So nginx can be used for load balancing and reverse proxy, caching the static content also. This same nginx can be used as a server, where you can deploy static website. Otherwise, if it is not a static website, it's a dynamic website. You can use here like a tool software like Tomcat, JBoss, if it is a Java based application, or if it is a Python based application or a Node.js based application, you can have a Python or Node.js installed, like that. So that is how load balancing is different, or static website is different. But nginx can be used for distributing the load also, and nginx can distribute the load to the nginx itself running in another system, if it is a static website. So you can use the software load balancers like this, that can be with nginx or httpd or HA proxy. Otherwise, there is something called cloud managed load balancer. If it is this way, you are responsible for creating a EC2, and you are responsible based on so much traffic comes to this load balancer. Again, this load balancer is distributing the load, but this also requires some CPU memory compute. And you are responsible for scaling this load balancing. You are responsible for creating and managing this compute, scalability, and configurations, availability you need to take care. But instead of this way, if I'm already using a cloud like AWS or Azure or GCP, we have something called cloud managed load balancers, or a fully managed load balancers. In AWS there is something called ELB. So this ELB is one service, elastic load balancer. It's a It's a fully managed load balancer service. You just create a ELB. In the background, AWS will create a required instances, required infrastructure to set up the load balancer. Once the load balancer is created, in this load balancer you can define the listeners rules. Rules means listeners means on which port this load balancer should accept the request. And rules means once the request comes to this load balancer on so and so listener, so and so port, to which group of servers it has to forward the request, that you can define. But in the background, AWS itself will take care of provisioning in load balancers, managing load balancers, scalability, like that. So that is how it is there. And again, whether you are using a software load balancer or a hardware load balancer or a cloud managed load balancer, that load balancers can be operated at layer 4, layer 7. We will discuss in a detailed way in further session what is layer 4, layer 7, and what is this SSL and TLS, how to use this. And again, there is a concept of domain names. Again, end users may not able to access or remember the IPs. Suppose you have configured a load balancer will have some public IP. Let's say this is the IP address of the load balancer. And this load balancer also will accept the traffic on some port. Most of the time, the default ports, HTTP port 80, HTTPS port 443, that will accept. Then it will internally distribute the traffic to the appropriate application system and application ports, like that again. But here, end users again no need to remember these IPs. It is hard to remember the IPs. This is where you can use something called domain name, different concept, DNS. You can map these IPs with some kind of a human readable domain names. If you see, our Rushi Technologies also have an application. We have developed and we got developed and we deployed one application to the students, right? But you guys no need to remember the IP of this where I have deployed this application, where we have deployed this application, this Rushi Technologies application also, right? We have deployed in some system, but I have used a different platform. Like I have used Hostinger, where I have purchased one server. We have used Hostinger. In Hostinger, we have purchased one server. There, I have deployed this application. But you guys no need to remember the IP of the server. This is like domain name, rushitechnologies.com. So what is domain name? Right? Domain is like a human readable name to that IP. It is very difficult to remember the IPs, so that we can use the names. Anyone can use the name. So what is DNS? How to use DNS? How to map DNS with your actual systems or a load balancers? And again, this is also secure. You can see HTTPS protocol. We are using this also configured with some SSL and TLS certificates. Like this, we will see what are all those things in a detailed way in further sessions. Load balancing, SSL and TLS setup, secure, that is HTTPS, and domains we will take it with real type of scenario only. A dedicated network, a private sub networks are there. We can, where we can set up our application instances, and a public subnets where I can set up the load balancer. And again, we will use SSL TLS, we will use HT, that domains concepts, all these things in a detailed way. This is very, very important concept. As a DevOps guys, we should be aware. In the interviews, so many questions will come, but if you don't know what is what, at high level, at high level only, if you know, that is not helpful for managing your work. And managing your work and clearing the interview. There is so much public content available on this load balancing. But that public content, whatever is available, right? There are so many public content already available. There are so many blogs people has created. There are so many YouTube channels and YouTube videos are also there in this DevOps and cloud, like this load balancer. But most of the people will explain, but not, they are not going to simulate the real infrastructure. What people will do, they will simply create a servers in the public subnets only. This application instances also public subnet, this load balancers also public subnet, right? And they will simply take one simple hello one, like that. That is also fine. But the way they are going to explain also not going to reach that real feel, that real flavor. But here we are going to do this way only, like private subnets where application instances, public subnets where load balancer. And again, I am going to use applications with the database also, right? We will use a database also. Again, when I am going to explain about RDS, right? So that time I will bring that one more application with the database integration. So as of now, whatever application I have, this is a dynamic web application only. This is a dynamic web application only, whatever we have already used and built and applied. But this is not having a logic to integrate with the database. It is not talking to any database and not storing and retrieving the data from any database. But same application, another version, same application, another flavor, another version I will take, and I will bring a load balance, I mean, say databases also. So we will see what is RDS again, what is advantages with RDS, what is how it works. That time we will integrate these applications with the databases also. A typical real feel will try to bring. But again, instead of manually building and deploying the application into these instances, every time there is a change in the code, instead of manually creating an application package, checking the quality of the code, checking the unit case, test cases coverage, again manually building, integrating, deploying, again it's a time consuming job. So then you already know what to do. Instead of manually building and deploying the application into these application instances, you can automate the build, test, integration, deployments also using what? Using CI/CD. Using CI/CD. And again, let's say this is so many servers you have to configure. Imagine you are using a virtualized deployment. Imagine you are using a virtualized deployment. First, you need to configure the systems with required softwares and configuration. Again, instead of manually configuring the required softwares and configurations here, then you can use, if it is a virtualized deployment, you are not using a containerized deployments or a containers, then instead of manually doing installations and configurations in these systems first, before you deploy your application, you need to configure the systems with required middleware softwares, required configurations like that. If required, you have so many servers to configure, manual configurations will take time consuming, error prone. Then what you guys can use, already we discussed as part of our DevOps program, that tool in a detailed way. You can use tools like Ansible, configuration management tools. And again, let's say you are not using a virtualized deployment, you are going to use a containerized deployment. You are going to use a containerized deployments. You are going to use a containerized deployment. In that case, you are going to build a package with application code as well as required softwares and configurations. The only required softwares in these systems is only container runtime like Docker. You don't need to install any softwares and configuration, because you are going to use a containerization concepts to build a packages with required softwares and configurations also. Required softwares and configurations also, you can build a package called a container images. And if you are using those container images to deploy the applications as a containers, that container contains everything, required softwares and configurations also. That time you may no need to use extensively these configuration management tools. And one more concept, suppose you are using a cloud like AWS, Azure, GCP. First of all, in order to run the applications, first of all, in order to do the installations and configuration, you need an infrastructure. This type of servers, this type of load balancers also you may need to create, or a clusters you may need to create. Again, instead of manually creating these required servers infrastructure, there is a infrastructure as a code tools, there is a infrastructure as a code tools, IAC, like a cloud formation, Terraform, like that. So that is how you have to understand the things, that is how you have to apply the things, that is how you have to learn the things. It is not like simply Rushi Technologies, Balaji sir is teaching easy to, let me go to AWS, let me click on this, click this, done. And since Balaji sir is again creating a load balancer, so he is clicking this button, let me click this button, and let me give this port number, let me give this, like that. Don't learn that way. Any tool, any technology, any framework which you are trying to understand, first learn why we are using that, what are the advantages of using that, what type of challenges or problems it is trying to solve. If you know the concepts like why, automatically you can understand how it will work. If you know why and how it will work, then you can do whatever you wanted to do with your requirements. So that is how the whole picture, whole DevOps is used, right? So DevOps is not a single tool, DevOps is not a single technology, it's so many tools, so many platforms bringing together in order to build, deploy, deliver and serve the applications to the customers with high availability also. So theoretically, I have explained what is the load balancer, what is reverse proxy, and also what we are going to do. Also, I have explained. So from here, I will continue in the next session. So as I already said, instead of directly explaining ELB, I will explain first this NGINX also. Maybe sometimes you might be using on-premise data centers. You may not use cloud. That time also same. So you can create a server and you can install a load balancer, software load balancer, or that load balancer can be run as a container also if required, if you are using Docker like that. So first I will explain this NGINX load balancing. Using NGINX we will do the load balancing, not for static website, I will for dynamic website. And again we'll do ELB also, we'll see. And later we'll see what is DNS, what is SSL, TLS, all these things also in further session. I hope today's session has given an overview about what is exactly this load balancers or a reverse proxy, how it will work, why we are going to use all these things. Okay. So that's it for today, guys, right? But without having a proper knowledge, without having a prior knowledge, proper knowledge, without a right direction, you may not able to understand all these things. If you observe, I am taking in one direction, the training whatever I am conducting, I have started with the basics, what is Linux, what is commands, slowly one after the other, one after the other we are bringing. Now if anyone directly look this, right, maybe they don't understand, because you should have also have a knowledge about what is network, what is sub network, what is public network, what is private network, what is route table, what is gateways. If they don't understand this, again they can understand load balancing, but that is not going to bring the real setup, right? So I hope already you guys, the persons who are enrolled for this course, right, I hope even though you guys are not attending the live sessions because of some various reasons, but I okay, but at least you should go through the recordings, you should practice whatever I am teaching. Then only you can easily crack the interview, then only you can manage your work also without any support, without any proxy. You don't need any reverse proxy for you guys, you don't need any reverse proxy for you guys to do the actual work and interviews. If you know the if you know the concept of reverse proxy, you don't need the proxy again. People are asking for proxy because they don't know what is proxy. First of all, if they don't know subject, then only they will ask the proxy support like that. But if you spend some time while teaching, even though it takes time, my trainings you already know, it is very basics to advanced level from zero to hero, right? Or but you guys also should have a same patience, same enthusiasm, same energy, same commitment, right? Like me, right? So if you have that interest, personal interest, enthusiasm, commitment, nothing is difficult, everything is easy. I hope you guys can practice this. You guys are going through the recordings who are not attending live sessions for various reasons, I don't know, because I don't want to get into that, because you may have so many personal reasons, but you guys are practicing, understanding, going through the recordings and giving, completing the given assignments, then you can easily do this, right? If you stuck anywhere, anytime, you can message me, you can message me in the group. We have a dedicated Discord groups for each batch, and there you can post me the questions, queries. I am always available to help you. But when I asked some assignment yesterday, only few guys has done that assignment, that VPC pairing. I don't know what about others. So try to complete as early as possible before we go for this implementation in the next session. Okay. Thank you. That's it for today, guys. If you have any specific questions, specific queries on whatever content I have explained today, let me know. Otherwise, I will stop the session here, and tomorrow we will go and do this setup implementation. Okay, guys, if no questions, thank you. Have a great day. We'll continue tomorrow. See you tomorrow. Tomorrow also we'll have a session. Maybe tomorrow I will schedule the session from 7 to 8:30. 7 o'clock to 8:30 since it's a weekend. Right, I will schedule from 7 to 8:30 tomorrow. See you tomorrow.